And here is a more higher level illustration of how a query planning works. So first, your SQL query hits a parser, and a syntax tree is generated, right? And the transformer and generates a logical plan, right? And your optimizer from the logical plan generates a physical plan, right? And here, the real optimization happens from the logical plan to the physical plan, right? The reason being, the logical plan is actually what your SQL is trying to do. So is, let's say, join A, join B on the key, right? And there's really not much you can change, right? There's really not much you can optimize. But a physical plan is how your database actually executes this query on a single node or distributedly, right? And so the optimizer is a key of to fast query, and especially for joins, right? Because there are many ways a join can be executed, right? Different tables, the tables can be reordered, right? And you can select different join algorithms, and you can select different join strategies, distributed join strategies, or or other advanced features like runtime filter pushdown. And I'm gonna go into those details later. But the search space is enormous, and the difference between an optimized plan and an unoptimized plan can be several order of magnitude difference. And ClickHouse Planner uses a rule-based optimizer, right? It makes decision based on only on predefined sets of rules or heuristics, right? It has little consideration for the actual data distribution or the current database state. It probably knows like the tablet, like the file size or how many rows, but that's about it. No consideration for the distribution of the data, like the min max or histogram, right? And it's really nothing wrong with a rule-based optimizer, if you're not really doing complex query. So it really works for simple databases, but not really for those OLAP workloads. And so when you're using ClickHouse, if you're a ClickHouse user, right, when you write a query, oftentimes it requires you to write the hints with the query, like what join algorithm to use, and requires you to like order the table in the right way so it runs the fastest, right? But in comparison, StarRocks use a cost-based optimizer, and that's the first key differentiation of for efficient join operation, right? So the cost-based optimizer actually collects statistics and estimates the cost of each plan, and use a greedy algorithm to select the best one, right? StarRocks' own cost-based optimizer is natively built and is deeply integrated with the execution and the storage layer, right? And it's something about building a optimizer is that it's really deeply coupled with your system. It's different for every execution engine. It's different for every storage engine. So it has to be natively built, and it's almost impossible to get right on the first try. And thank God StarRocks is open source, so we could iterate that with the community, and it took us like a year or two to get it right. And this is the main reason why the query is efficient. And also StarRocks has a lot more other kind of optimizations, right? Like data pruning. So the objective of this is basically to minimize the amount of data that's being processed by your CPU. So let's consider this query, right? Select star from fact, join dimension table. Fact.dimension ID, dimension.id, right? Where dimension.price is greater than 100, right? And so let's say the fact table has a billion rows and scans a billion rows, and the dimension table scans 1,000 rows, right? So what if we can send this predicate to the fact table, and it can save a lot of the data that's being scanned, right? So it can possibly go from 1 billion to 1 million. But there's more than that. So this predicate, this column might not even exist in the fact table, right? So simply sending the predicate itself over, it's not going to work, right? So what StarRocks does is it has the option to send a Bloom filter from the dimension table, so the right table to the left table, right? And thus still do this 1 billion to 1 million row optimization, right? But this is a little more complex than just that, because sending this Bloom filter over has its cost as well, right? Is the cost of sending the Bloom filter worth it? That's a question that our cost-based optimizer needs to answer, right? So is the filter worth the network cost? Probably yes, probably a no. Right? And this is something we've optimized for a very long time.